Welcome to our intermediate algebra course. And what you will find, these videos will supplement all the presentations that we have during that week. So any of the, since this is a day one video, the slides from the day one presentation you'll find here in the video. So they will supplement and correspond very nicely. And so anything that may not make complete sense during class, you can always come back on your own time and check out the videos that support that day's work. So got the objectives for that day, for day one, and looking at factoring. And so I want to look at this first one here, and I'm looking for the GCF, greatest common factor of 35 and 60. One method is to think of factors of 35, so 7 times 5. Think of factors of 60, and maybe 10 and 6 was the first factors that came into your mind. Okay, well, none of them are the same, right? But 7 and 5 are prime. 10 and 6 are composite, which means these would factor into 2 times 3 and 2 times 5. Well, now that you scan them all, you see that 5 is the greatest common factor. So, greatest common factor of 35 and 60 would be 5. Next one, we're going to look at part B. I've got 4x squared, y to the third, 16x to the third, y to the sixth. So we always want to look at our coefficients, just like the previous one with 35 and 60. Well, now we're looking at 4 and 16, and I want to know what's the greatest common factor. Well, 4 is actually a factor of 16, so the greatest common factor of 4 and 16 would be 4, but we still have the variables, so you don't want to forget those. So over here, you've got 2 x's, and over here you've got 3 x's. And over here you've got 2 x's and 3 x's, and over here you've got 3 y's and 6 y's. 1, 3, 4, 5, 6. So when you're looking for the common factor, you're looking at 2 and 3. It's what they have in common, and they only have 2 in common. So you get x squared, and it happened to be the smaller of the 2 exponents. Here you've got y to the third and y to the sixth. Well, the only thing they have in common are 3 y's, so it would be y to the third, and notice it would be the lower of the 2 exponents. Your GCF would be 4x squared, y to the third. Next one, we're looking at 63 and 84. And with 63 and 84, maybe 9 times 7 comes to mind. And, well, I see that 84 ends in 4, so maybe you divided it by 4, and you got, 4 and 21? Well, notice they don't have anything in common. So you can keep simplifying, because 9 is composite. So 3 times 3 times 7, and 4 would be 2 times 2, and 21 would be 3 times 7. So you're thinking, well, what do they have in common? All right, so be careful here. You see they have a 7, right? But you also see they have a 1, 3. Well, that means your GCF, since all of these are being multiplied, correct? It's 7 times 3, or 21. The greatest common factor of 63 and 84 would be 21. Next one we're looking at is 25x squared and 60x to the fourth. Notice you're working with x squares and x to the fourth, so you probably have a good idea of how many x's would be involved here as a greatest common factor, and it would be 2 because it's the smaller of the 2 exponents. 25 and 60. Well, now you're thinking, well, that's 5 and 5, and 60 would be 5 and 12. Notice they both have a 5 in common, but now you look at these other two. 5 and 12, did they have anything in common? And the answer is no. So your result would just be 5x squared as your greatest common factor. And last, we've got 36 and we've got 90. And so if you're thinking factors, you might think, well, 10 and 9 may be the first thing that comes to mind, and 36 would be 9 and 4. Well, they both have a 9, but don't be quick to just jump to that, because look at 4 and 10. They're composite. So what you're going to have here, 4 factors into 2 times 2, and 10 factors into 2 times 5 times 9. So what do they have in common? Well, they've got a 9, and what else? 1, 2. So 2 times 9 is 18. Of course, that 2 times 9 is 18. So the greatest common factor of 36 and 90 would be 18. 9 would be a factor. It's just not the greatest. Next set of examples we talk about in class is factor the polynomial by factoring out the GCF. So what we're going to look at for all of these examples is, what does each term, that's a term, that's a term, that's a term, what does each term have in common? So 12a to the third, b to the fourth, plus 16a to the fourth, b to the second, plus 20a to the second, b to the second. And I would encourage you to look at your coefficients first. And you look at 12, 16, and 20. And it looks like the greatest common factor would be 4. And now let's look at a's, a to the third, a to the fourth, a to the second. What's the smallest? A to the second. Third, we've got b to the fourth, b to the second, b to the second. So b to the second would be. Now, that's the greatest common factor of all three. But when you factor out this term from all three of these, it's like you're dividing. So what's 12 divided by 4? 3. What's a cubed divided by a squared? A. This is coming back to our exponent rules. When we're dividing, we're allowed to subtract the exponents. B to the fourth divided by b to the second would be b to the second. What's 16 divided by 4? 4. A to the fourth divided by a to the second is a to the second. B to the second divided by b to the second is 1, so I don't have to write that. 20 divided by 4 is 5. A to the second divided by a to the second is 1. B to the second divided by b to the second is 1. So what we have is this would be our factored form. Notice these numbers here, 5, 4, and 3. They don't have anything in common besides 1. So that tells us that we were correct in finding our greatest common factor of 4. Next one, we've got 25xy minus 50xz plus 100x. Remember, our practice here is just looking for each term a greatest common factor. And 25, 50, and 100 looks like it's going to be 25. 25 is a factor of 50. 25 is a factor of 100. X, X, and X, they have an X. Y, no Y, no Y. So Y is not a factor. Z is only here, so Z is not a factor. So the greatest common factor of these three would be 25x. But now we've got some remaining terms. 25xy divided by 25x would just be y, minus 50xz divided by 25x would be, well, 50 divided by 25 is 2, x divided by x is 1, and there is no z to divide out. 100 divided by 25 would be 4, x divided by x would be 1, so you're left with this as a factored form. 8, a to the fifth, b to the sixth, minus 32, a to the fourth, c to the second, plus 40, a to the third. You're looking at each term again, and you're looking at 8, 32, and 40, and the greatest common factor would be 8. a to the fifth, a to the fourth, a to the third. The smallest would be a to the third, b to the sixth. There's no other b's, so we can't factor out a b. And so b's and c's, as you notice, are not in all terms, but the a is in all of the terms. So that's why you see an a as a factor. So 8, a to the third, is the greatest common factor from all three terms. And so now we go with our division. 8 divided by 8 is 1. A to the fifth divided by a to the third is a to the second. B to the sixth minus 32 divided by 8 is 4. A to the fourth divided by a to the third is just a. C squared has nothing to divide out, so we're going to leave that as c squared. And 40 divided by 8 is 5. A to the third divided by a to the third is 1. So we have a greatest common factor of 8a to the third, and then we have a result, our factored form. You know, if we multiplied this term by each of the other terms, we would come back to this original. 30x cubed y z to the second minus 24x squared y to the third z to the fourth. Now with these videos, a lot of times when I copy it down, it might be a good time to hit pause and then you try to work through it yourself, and then you can come back and check your work with what I have. Okay, 30 and 24. Looks like greatest common factor looks like 6. X to the third, x to the second, looks like x to the second, y to the first, y to the third. Notice there's not an exponent there, so you've got to understand that that's y to the first, and z to the second, and z to the fourth, so z to the second. Now take each of these two terms and divide it by your greatest common factor. So 30 divided by 6, 5. X cubed divided by x squared is x. Y divided by y is 1. Z squared divided by z squared is 1. 24 divided by 6 is 4. X squared divided by x squared is 1. Y cubed divided by y is y second. Z to the fourth divided by z squared is z squared. 28a to the third, b to the third, c, minus 36, a to the second, b to the second, c. Two terms. So in my parentheses, I should see two terms as well. 28 and 36. Looks like 28, 36, so 7 and 4. And 36 would be 9 and 4. And notice that 7 and 9 don't have anything in common, so 4 would be our GCF. A to the third, a to the second, going with the lower amount of exponents, so a squared. B to the third, b to the second would be b to the second, and c to the first, c to the first, so it would be c. Remember, take this term, divide it by this term divided by this term, and that will fill in your spots here. So that would be 7, A, B, and 9, because a squared divided by a squared, b squared is b squared, c, c, just left with 9. There's your factored form. Now, these next 5 will involve factoring by grouping, and then we'll look at our check for understanding. This is a very important step, as we talked about in class. One of the methods for factoring a quadratic, when a is larger than 1, and this would be our a value, when a is larger than 1 is to use a grouping method. And so what we do when we have our 4 terms here is that we group the first 2 and the second 2, and we look for GCF in both parentheses. So 6 and 8, greatest common factor would be 2. X squared and x would be x. So what do you have? 6x squared divided by 2x, and you get 3x. Minus 8x divided by 2x, and you get 4. Now notice this is a positive 9x, and this is a positive 3x. I would like to keep a positive factor, so I'm going to think, what do these two have in common? And it is 3. Notice it's not 3x because this term doesn't have an x. 9x divided by 3 is 3x, and notice that they start to match up. 12 divided by 3, or you could say it as a negative 12 divided by 3 would be minus 4, and notice that they repeat factors. So what you say, what I underlined there was 3x minus 4 is one factor, and what's remaining? 2x plus 3 would be the other factor. So if I give you 4 terms and ask you to factor by grouping, this is the result that I want. Next one, we've got 9x squared plus 15x minus 12x minus 20. Notice this is a subtract 12x, so I'm actually going to make this an addition of a negative. So I'm going to put the parentheses around those two, 9x squared and 15x. The GCF would be 3x. Both terms have a variable. That's why a variable is part of my GCF. 9x squared divided by 3x would be 3x, because 3x times 3x gives you 9x squared. What's 15x divided by 3x? 5. How do you check? 3x times 5 is 15x. Now, I wrote it this way because notice that that 12x is negative. And I want, this is a positive 3x, and I would like for my other term to be positive. So what I'm going to do is factor out the GCF between negative 12 and 20, and it would be negative 4. What's negative 12x divided by negative 4? 3x. What's negative 20 divided by negative 4? Positive 5. Like we said, they should match up. So you're left with 3x plus 5 in parentheses, and what's remaining? 3x minus 4. Now that's your result. If you wanted to check, you could multiply this out, and you would get 4 terms that would match here. 4x squared minus 10x plus a negative 10x plus 25. So I'm going to group 4x squared minus 10x. The GCF of 4 and 10 would be 2. The GCF of x squared and x would be x. So you're left with 2x minus 5. This term is negative. This one's positive. I want it to be, this first term here, to be positive. So I'm factoring out a negative 5. Why negative 5? Because it's the factor, greatest common factor of negative 10 and 25. What's negative 10x divided by negative 5? 2x. What's 25 divided by negative 5? Negative 5. They match up. So I'm left with 2x minus 5 and 2x minus 5, which is a special one. It's called a perfect square trinomial. Okay. If we multiplied this out, we would get a perfect square trinomial. We can also write this as 2x minus 5 quantity square. Both of those mean the same. Six x squared plus 10x. You see how that's a minus 24x? I would encourage you to write that as plus a negative 24x and then minus 40. And now we're back to group, find the GCF. So GCF of 6 and 10 would be 2. GCF of x squared and x would be x. So that would give me 3x plus 5. And since this is negative, I'm going to factor out a negative. I've got 24 and 6, so it looks like 24 and 40, and that would be 8. So what's negative 24x divided by negative 8? Be 3x. What's 40 or negative 40 divided by negative 8? And that would be positive 5. So notice these are matching up. So I get 2x minus 8 and 3x plus 5. Now this one could also be written, since it's 2x minus 8, I could factor a 2 out there and I get x minus 4 times 3x plus 5. So either of those would be correct. Last one, I've got 12x squared minus 20x plus 18x minus 30. This term is positive, so I'm going to go ahead and group those two and these two. GCF of 12 and 20 would be 4. X squared and x would be x. 12x squared divided by 4x would be 3x. 20x divided by 4x would be negative 5. 18x and 30. Looks like 6. 18x divided by 6 would be 3x. Negative 30 divided by 6 would be negative 5. So we have 3x minus 5 and 4x plus 6 would be your factored form. And this could also be written, as I said, since these two are both have a common factor, it could be 3x minus 5 and 4x and 6 would be 2, so that would be 2x plus 3. So both of these are in factored form. Which leads you to now the check for understanding. And this would be, I want these factored completely. So number 1, 8x minus 24. You're looking for what both terms have in common, and they both have a factor of 8. So 8x divided by 8 is x. 24 divided by 8 is 3, and that would be a factored form. How can you check? Notice I have up here optional. You can check by multiplying. 8 times x is 8x. 8 times negative 3 is negative 24. You should come back to where you started if it was factored correctly. Number 2, I've got 18r to the 4th minus 27r to the 6th. You're thinking of 18 and 27. What do they have in common? It should be a 9. R to the 4th, R to the 6th. Remember, you're going to take the smallest of the two. What's 18r to the 4th divided by 9r to the 4th? That would be 2. What's 27r to the 6th divided by 9r to the 4th? That would be 3r to the 2nd. And that would be your factor form completely. Next two is a factor by grouping. So 8x squared minus 12x plus 2x minus 3. Since this term right here is positive, I'm just going to group here and group here. 8 and 12, what's the GCF? It's 4. X squared and x would be x. So this leaves me with 2x minus 3. Now, careful here. What do they have in common? The only thing 2x and 3 have in common is a 1. So you get 2x minus 3. So there's the 2x minus 3 showing up. So you get 2x minus 3 times 4x plus 1. And that would be the factored form. And then let's look at number 4, and that's 6x squared plus 2x. Notice there's a subtraction, so we can write that as plus a negative 15x minus 5. And then we can go on to our grouping. 6 and 2. 2x is the greatest common factor. Remember to divide both terms by 2x, and you get 3x plus 1 minus 5 is the greatest common factor with the numbers. So that's going to give you 3x negative 5 divided by negative 5 is a positive 1. So you're left with 2x minus 5 and 3x plus 1 would be the final two answers for our check for understanding.